Okay. Hi guys. We'll be doing some online classes, online videos like this. So due to the previous situation, and we'll just continue with your syllabus, I guess. Okay. So I still remember the last time we stopped with your syllabus was at the point where we spoke about organic chemistry, where we started to speak about organic chemistry, and we spoke about very simple things related to organic chemistry, which was simply like naming what are organic compounds, how to name them, and different structures, and so on. So now we come to the next step in this organic chemistry lesson, which is we will classify these organic compounds into various organic compounds depending on their unique physical and chemical properties. So mainly in your syllabus, you'll be talking about mainly about 4 or 5 different groups of organic compounds, and there are different ways, and you'll be learning why we and how we are going to classify these guys into different groups. Okay, the most easiest and the first thing that comes to the mind of anyone who knows organic chemistry will be alkanes. Okay, so you guys will be also doing the first thing will be alkanes. We'll look upon what alkanes are. Okay, so here we go. So what will be covering in this video, we'll be learning about what alkanes are, which is the most important thing, and then reactions of alkanes, because chemistry is more sort of, we always speak about reactions, chemical reactions that take place here and there. Okay, so for the first time we learn what is an alkane. Okay, so alkane is simply, okay, so in the initial part, so you guys learned about uh, hydrocarbons. So what hydrocarbons means is hydrocarbons is a compound which contains only a carbon and hydrogen. So this alkane is an example of a hydrocarbon, but there's a small unique feature it has. Okay, so one of the unique features you would see is that an alkane will always have a carbon-carbon single bond. Okay, so for example, if I'm going to show you something, so you can see here, there's an example I've given out there. That structure, you will see a carbon, I guess you guys know what the name of this particular compound is. Okay, I hope so. Okay, if not, try to revise from the previous one and try to name that particular compound that's been given out there. Okay, so we need to know, the important thing we need to know is an alkane has a single carbon-carbon bond, or carbon-carbon single bond, and it's a hydrocarbon. Why is it a hydrocarbon? Because it contains only elements of carbon and hydrogen. If someone wants to add an oxygen, then that's not a alkane. Okay, so now being a simply a hydrocarbon, or just having a carbon-carbon single bond, does not give it a very unique feature. Okay, so the thing is, when we look at a particular molecular formula or a chemical formula, we need to say, okay, that's an alkane. So how do we do that? There's a particular form. Okay, so for example, this formula, this CnH2n plus 2, would be the one that would give you that particular idea. So for example, if you want to wondering what this n means any integer value. Okay, so when I say integer value, they cannot be fractions. They should be always whole numbers. Okay, whole real numbers, and they should not be negative numbers. They could be only positive whole numbers. Okay, so for example, if you put something, say you want to put n equals 2, then you get an equation of Cn, and then you, for the hydrogen, what do? 2 multiplied by that 2 plus 2, so C2H6. Okay, so simply you can do until because you guys need only up to 5 carbons, and you guys need to know what the names of until the 5th carbon is. So I guess if you guys just go on adding into this particular equation, you guys will find out all the five alkanes that you guys need to know, right? There's a basic idea what alkane is. So this is a example of alkane, and you guys, I hope that you guys know what the name of this alkane is. It has two carbons, and you can see here clearly you can see here that there is a carbon single bond, so that definitely is a alkane. Okay, and you guys could write the name of this particular element, what this particular compound is, for your understanding. Okay, so let's look about the physical properties of this of alkanes. When we talk about physical properties, we associate physical properties with melting points and boiling points. Okay, low densities, then solubilities and stuff like that. We don't react anything. For example, we don't, when we consider physical properties, we don't react it with an alkane with water and then see what happens to it. We don't care what happens. When we require about the physical properties, what we require about solubilities, melting points, boiling points, densities. That's what we will look into this. So you can see it says relatively low melting and boiling points. So relatively low melting points and boiling points means compared to other organic compounds, it has low melting points and boiling points. Similar for densities, relative low densities. So that means that it doesn't mean that this has the lowest density, but compared to other organic compounds, yes, it does have relatively lower densities. It's insoluble in water. So all these alkanes, all these compounds that we'll be discussing are gases. Alkanes are gases. Okay, so keep that in mind. And in certain cases, there is a possibility of being soluble in organic solvents. For example, like benzene or something like that. Okay, so those are the basic physical properties, and the reason why we have these physical properties are, so for example, if you want to distinguish something, okay, maybe distinguish maybe ethane and methane. How do you do it? Because both of them they're colorless and odorless. So when I say colorless, that means it doesn't have a color, it's transparent. When I say odorless, that means it doesn't have a smell. So you cannot use your sensors to identify them correctly. Maybe you could play a TikTok game and then do something, but scientifically you can't do it. Okay, so then we need to have another parameter, so we could use maybe compare the boiling points or compare the melting points, and then come exactly to a conclusion as to what is what and what is ethane, what is methane. Okay, so simply it's for a validation that we use these techniques, and that's why we have physical properties, and that's why we need to learn about physical properties. Okay, so next we will go to the chemical properties. So in this chemical properties is the most important thing. Again, where you would get a lot of questions, and then you got to have balancing, and then sometimes you end up missing things around in this. So, but there's not much to learn. Okay, there's just two reactions associated with alkanes. The first one is a combustion reaction. Okay, so when we say combustion, if you remember from your previous lessons, combustion is when you burn something in oxygen to produce simply carbon dioxide and water. Same thing we do here for alkanes. We are burning alkane, any alkane, it could be ethane, it could be methane, it could be propane, anything, with oxygen to produce carbon dioxide and water. Okay, so that's now the products of carbon dioxide and water are a must. This is the fundamental equation. It doesn't change for any alkane. It could be decane or something like that. If it burns in oxygen, it will produce carbon dioxide and water, nothing else. Okay, and you know that it's a combustion reactions. You know that it's a exothermic reaction. Okay, so energy is being given out, or energy is being produced from the reaction to the surrounding. Okay, that's the first reaction, combustion reaction, which you guys are very familiar with. And you can see the example that I have given is CH4 plus oxygen. CH4 is methane. So methane burns in oxygen to produce carbon dioxide and water. And balancing equation is really important. So that's why I have given there the reaction with balancing also. Okay, so the next one. The next reaction is the new one, the substitution reaction. Substitution means, substitution is a pretty relatively familiar word. You know, if you guys watch sports, okay, if you guys watch sports, and especially if you watch team sports, except for cricket, there are situations in football, like games in football, where you see players being substituted. Okay, so for example, what happens here is, in football, what happens is the player gets substituted. So for one player, another player goes out and another player comes in. So here we don't speak about any players or something or people. We compare here about elements. So what here fundamentally what happens here is always, okay, in most cases, what happens is always a hydrogen will get substituted by a halogen. So what's a halogen? Halogen is basically a group 7 element. So here you can see a reaction between methane and bromine. So one of the bromines will get substituted with the hydrogen, giving it this formula here. Okay, so because bromine has 2 bromines, it doesn't mean that both should come and get fixed into this product. No, there's nothing like that. For one hydrogen, one bromine will get substituted. Okay, that's a must. That's it. And then you get a byproduct called HBr, which is hydrogen bromide. Okay, so that's a byproduct. So that's the basic reaction. Even if you have chlorine, if you have iodine, normally substitution happens with halogens only. Okay, you will be learning in your syllabus only with halogen. Okay, once you go to upper grades, you will learn about different things, but for now you will learn only this. Okay, now this reaction, okay, these bonds between like to start this is very difficult. Okay, you can't just bring them together and then see for a reaction to happen. So we need some other source for this reaction to happen, and the source that we use is UV light. So UV light, or I have shown you a sun. So sun is UV light. So the point of having UV light is we can understand that the UV light always produces a great amount of energy. So to start this reaction, we need a large amount of energy for these bonds to be broken. For these bonds to be broken, we need a large amount of energy. So the bond energy between carbon and hydrogen and between bromine and bromine are relatively high. Okay, so that's the whole point of understanding why we need a source for this reaction to start. Okay, then we come to the last part of this entire lesson, which is we'll talk about the trends in physical chemical properties of alkanes. Okay, so now in alkanes, if you start from the first, if you have one carbon in alkane, we call it a methane. Okay, and the last one that you need to know is about hexane. Okay, so if you go from methane to hexane, you will see the boiling point increasing. Why? As the number of carbon increase, the boiling point and the melting points increase. It applies, the same theory applies for densities also. Okay, if you consider about a chemical property, the one that has the most number of carbons will be higher reactive when compared to the one that has the lesser. That means hexane will react with anything more quicker or more rapidly when compared to methane or ethane. Okay, so these strengths are very important because in certain cases it will be helpful for you to distinguish them and for your academic purposes. Okay, so that's it for the uh, yeah, for this lesson about alkanes, and I'll see you again for our next video with a new lesson. Okay, thank you.